because if he doesn't, he's screwed.
Yeah, we don't have very many weapons, do we? We have fingernails.
See that hair? See how that fares against a football mind?
They have fingernails too, don't they?
Yes, they do.
You have fingernails?
I saw a video.
I said humans aren't that time.
Okay,
Change,
look up,
compare yourself to like a lion.
Alrighty, so let's go ahead and continue with
If the human doesn't have a weapon, they don't have a chance.
addressing modes. You know, this is going to be a fun topic. Okay, because there will be people several weeks from today asking me questions that will be related to this. Okay, so this is one of those topics where when we talk about it, it doesn't seem to be very important, seems kind of boring, seems kind of dry, and then later on it's going to be like, oh, okay, so that is actually useful. Alright, so let's go ahead and get started with addressing modes. For those of you who remember pointers, okay, so you might want to recall pointers in C and C++ because some of these addressing modes are actually closely related to the use of pointers. And of course, I think most all of you have read this section already, as per my recommendation, in the syllabus, right? Yes. Frankly, when I was a student, I never did that. So.
How dare you?
Not that I turned out to be very successful, but I did survive. All right, so we'll start with, we finished this part already, categories, okay, because there are 3 categories, and that's universal to almost every architecture that I know of. So there are registers, there's an immediate operand, and there are also memory operands. Some really weird architecture may not even have immediate operands. Now, you might ask, but without immediate operand, how do we get a particular value into memory or something? Well, you have to load everything into memory, so you can only load from memory into the registers. So that's how they get around with that particular issue. But most common architectures have these 3 different types of operand categories. All right. So moving on to, we did an example program the other day, and I never really quite finished tracing it. So let's go ahead and trace that particular program. Let's open up a terminal. Go back to that note. Okay, so this is 0207 cisp310. All right, so this is IMREG for immediate and register. All right. So are there any questions? Okay. So let's go ahead and actually link the program. I did not even have time to link the program last time. So let's go ahead and do it. ld-o imreg.o. All right. So this program doesn't really do anything. If you run the program itself, it doesn't do anything. It doesn't crash, but it just exits normally with no input output. Our programs will look like this for, I would say, for the next few weeks. Okay. So until we get to system surfaces, so that you can do something to print out to the screen and read something from the keyboard. This is all that we can do. So that's why we need GDB, which also brings up a point that I needed to make. To do your homework assignment, some of you tried to install GDB and it did not install because your catalog is out of date. Okay, the repository catalog is out of date, so it's pointing to a file that is no longer around. So what you need to do is you either read my latest email that I sent to everyone in the class, or just kind of follow this procedure. So what you want to do is to do an aptitude upgrade, and then you do aptitude install, blah blah blah, whatever you want to install. Okay. So the first command, aptitude update, brings the catalog itself up to date, so we have all the current files. And then the second command is the same command that we used before to install the necessary packages. Now because of this, I did not anticipate this problem, so I'm giving you guys a little bit more time to turn in your homework. You do not need GDB to turn in your homework. Okay, there's no way for me to tell whether you were able to use GDB to debug your program. So you can turn it in without using GDB. So you can just go ahead and turn in with all the files that are already there. But this is a useful command because in the future, in case we want to install any additional packages and it doesn't install because the catalog is out of date, this is how we can bring it back up to date. right? So a little digression because of that. But for this particular program, we do need GDB because otherwise the program doesn't seem to make any sense. When you say GDB, you say GDB and then the name of the executable. In this case, the executable is imreg, which is the output of the linker, the LD command. Inside GDB, okay, the first thing is, if you don't remember anything, you can always say help, okay? So help can help you with different types of classes of commands. For the most part, in this class, breakpoints are useful, data is useful, running is useful, and that's pretty much it. Okay, you don't have to read everything, but I will explain the commands in this class anyway. L is to list the program. If you just say L or list, it will basically list 10 lines at a time. If you press the Enter key, it will list the next 10 lines. If you press the Enter key, it will list the next 10 lines. The Enter key is basically saying repeat the previous command. Okay. So right now we have this command, and remember, no op, NOP, doesn't do anything. It's only there because I cannot put a breakpoint on the very first line after underscore start. So that's why it's here. But what I want to do is to break on line 5. Okay, so I'm putting a breakpoint on line 5 right here. Did I run this program last time? I could not have because I don't see the executable, so I could not have run the program. So this is putting a breakpoint. Does everybody understand what a breakpoint is in the debugger? Okay, let's move one step back. Does everybody understand what is a debugger as a tool? Okay, yes? You're sure? Okay. Well, I need to make sure that I can establish what a debugger is first, because there are people who can write programs and debug their programs without ever using a debugger. Okay, for a little bit of time I was doing that because there was no debugger back when I took the Pascal class. So there's no way I can debug my program using a debugger. So printf or write line back in those days was the technique. All right. So once you know what a debugger is, putting a breakpoint is, okay, I will just let somebody else say that instead of me. Just pretend that I don't know what a breakpoint is. Go ahead.
It's going to run until the line 5 and then stop.
Exactly. Would it stop before the stuff on line 5 executes, or would it stop immediately after whatever is on line 5 executes?
Yeah,
Before.
Yeah. It's a tricky one, okay? But it does, it stops before, in this case, the instruction on line 5 executes. It's the same thing with C and C++. If you put a breakpoint on a particular line, the program stops execution before whatever is on that line executes. Okay, so it's something nice to remember, because you will probably encounter that question from time to time. So in this case, I put a breakpoint on line 5, which means the program will run at full speed until it gets to this line, which is the first line that is interesting. No op, as the name implies, doesn't do anything. It's really just a placeholder. It just takes up memory, space and execution time, but it doesn't really do anything. All right. So we are now ready to run the program. So R to run the program, you can type out. You can type RUN, but R, works just as well. So now the program has stopped. Okay, it says it's at breakpoint 1, and it is stopped on line 5 of imreg.s. Okay, if you read this portion of the screen, it tells us where it is at this point. If you have a project that has multiple files, this information can be helpful, because when you put a breakpoint, it might go to a particular file before it stops. So it's always good to check which file am I in when you have a multi-file project. The next line here displays the actual source of line 5 in that file, and we are just about to execute this instruction. I can look into EAX and see what value the register has at this point. It displays the number, the value, in two ways. For this one, it seems kind of silly because 0 is a 0 in hexadecimal or otherwise. But in other cases, being able to look at a value in hexadecimal and also in decimal can be helpful. So in this case, 0 is 0, doesn't do anything. When it's time to single step, you use the command step, or just the letter S would do just fine. That will execute one instruction at a time. Okay? Instead of running the program at full speed again, it will just execute this one single instruction on line 5. So I'm going to press the Enter key, and now we are about to execute line 6. But before we execute line 6, we'll take a look at EAX again, and this time it shows that EAX has a value. It will only use whatever number of digits is necessary to display the number. Even though EAX is supposed to be a 32-bit register, it only displays the number. It only uses up 2 digits, in this case in hexadecimal, because that's all that we need in order to display the value. In this case, it also says D8 is the same as 216. Hexadecimal D8 is decimal 216. Now, since we are going to move from EAX into EBX, maybe we should check EBX and find out what value it has at this point. It is 0. All right, single step again. I'm executing line 6 in this case. And then I can look into EBX again, and you can see now EBX has the same value as EAX, because the move instruction in AT&T notation copies the value from the first operand to the second operand. Are we doing okay so far with the debugger and what we are seeing? Is that okay? All right. So at this point, the really meaningful part of the program is done already. I can use Q to quit the program, or I can use C to continue execution of this program, because this program does contain the proper exit code, so it will exit correctly at the end of the entire program. So either way works. Okay, if you type Q, you can get out right away. But it will give you a warning because your program is not done yet. So it will give you this warning and say, oh, okay, your debugging session is still active. Are you sure that you want to get out at this point? So it gives you one chance to say no, I'm not quite done with debugging this program. I want to continue. So you can say no when they ask you that question if that's not what you want to do. Okay, if you don't want to quit, just say no, and it will throw you back into GDB so you can continue to debug your program. Any questions at this point?
How is that? I mean, I see that this is helpful to find a problem, but how say the problem had a bug, and how would you go into it and fix it using the debugger?
The debugger cannot fix the problem, but what it does allow you to do is to stop execution at certain points, and then you can also examine, well, in this class we don't use the term variables. We just say you can examine memory locations. There are specific reasons why I do not use the term variable or the term type, because there is none in assembly language programming. But you can examine memory locations. So what you can do is to look at the registers, look at memory locations, and then you can step by step, you can basically, if you think a bug is down here, you can put a breakpoint like a few instructions before that, then you can single step, at least to the point. Exactly.
Okay.
So all the same debugging techniques that you know in C and C++, it still applies here, except we have a little bit more insight into all the stuff behind the scenes. So, okay. This classroom is a little bit cooler today, but now it's getting warm. I think it's because of all the people in it. Because each person is what, 200-watt heater? Is that about right? Yep. So I can quit this program now, and that kind of concludes this particular debug session. Are there any questions about the debugger?